Yes, over 8. Yes, next Monday. Today you'll probably like, as we get into using your graphing calculator to solve these things, so it helps out a bit with that. Two pieces of stuff for you today. Once I get my other stuff here in line. More story problems. I know. There you go. Yep. One more. All of you have your graphing calculators with you? Hopefully. Because whoops, stop. Wait, hold it. Stop. Wait. Wait. Get that one. And this one. Hold it. One more. There you go. Yep. If you didn't, I brought an extra graphing calculator. Somebody needed one that didn't bring theirs with them. Because we will use them today with stuff. So is there anything from 8.3 or 8.4 that we still need to take a look at and go over? Anything? Or do you think you're pretty good there? Okay. If you think you're pretty good there, then I guess we will move on and proceed to other things. Today, I want to flip-flop your two sections. We're going to start with 8.6, and then we're going to go back and do 8.5, but we're not going to do 8.6 the way Hawks does 8.6, okay? In Hawks, when they do 8.6, they go through and solve a 3x4 matrix using algebra. But we are not going to do it that way. We're going to use your graphing calculators to do that and use your matrix button. Because it takes quite a while to solve one of those using the method they use in your Hawks part. The homework, though, that pops up in there, you can still use the same system of using your calculator to solve the stuff in 8.6. It's just do not use the method that Hawks uses. The bad part about that can be that you can't use the tutor button, but you probably won't need to, because when you use your graphing calculator, you will automatically be able to work with that and know what you're doing with it. So you won't have to use that part. So in 8.6, we're going to do a 3-variable matrix. And so our objectives for this part are to solve linear equations in 3 variables, and then solve applied problems using the systems of linear equations in 3 variables. So we need to, first, I handed out to you a sheet that has your matrix information on it, on how to use your graphing calculator. So you guys should all have that sheet. If you are watching this video and you're in my online classes, your matrix sheet is in your week 6 section, and you will be able to find it in there, and you can copy it off and use it at, wait a minute, Taylor, use it at that point. So get your graphing calculators out, because we're going to walk through and set them up for you so that then we can end up using those to solve your systems of equations that you happen to have. Well, what on your calculator, and again, I gotta see if I can find the spot where this thing shows up without being on top of my writing or the stuff that's in here to take a look at. Looks like that's about a good spot in there. In your calculator, it says get your matrix in your calculator. It should be the second key is needed to get to it. So our second key is up here on our keypad. Your matrix button is right below your math button. Everybody find that? Your second key, your matrix is right below the math button. And notice in my case on my calculator, you can't see it on here, but it is in light blue. I don't know, yours might be yellow or it could be a variety of colors because it seems that Texas Instrument kept changing those colors. So if you go second, hit your matrix button, it's going to end up showing you that piece of information, and we can put into this calculator up to 10 matrices all at once. It's kind of confusing. The most that we're going to use it for is probably one at a time, or two at a time, basically, is what we're going to take a look at. So if I go through this, the first thing I want to do is, of course, get there, and I want to, within the matrix, go over to edit. So I'm going to hit my over arrow key, and then I'm going to go to edit. Everybody there? Edit. And first I'm going to go to A, which is on right now. It's highlighted on A. And I'm going to enter a 2 by, and it's going to have X's in there. So all I did was hit the 2 and it goes to that. Everybody got that? And then I'm going to go over arrow, and I'm going to hit a 3. And so, or hit enter at that point. And then I am going to go back to the to edit it, and I'm going to get that under A. Now what this is a 2 by 3 is what we've been solving using algebra. That's the ones we've graphed. That's the ones we use substitution for, and that's the one we use addition for. And so that's that 2 by 3. So that's what we've been working with. So now I'm going to go second, and above my mode button is quit. So second, quit. Then I'm going to go second, matrix again. And I've got mine in my wrong location here. Somehow, I don't know why it put it into that one instead of into my A. Let me go down here and let me get rid of this part. And I'm going to go back to a 1 by 1. Always, whenever you're doing something that you are setting stuff up for the first time, it seems to have that habit of getting me not where I want to be. So I want A. Whoops. And I hit my 2 by 3. And then I'm going to go second quit, second matrix. Now I'm going to go down to B. So this is where you guys should all be. So go down to B, go over to edit, then go down to B, I guess, and then pull that up. And we're going to do a 3 by 4 matrix for that one. And these are locked in now. They're your A and your B. So when you're doing matrices, and if I go second quit, second back to matrix, it's going to have those set up in there, okay? So if you are doing a 2 by 3, which we will do when we do our story problems from 8.5, because we're going to use our calculators to solve those because I got a lot of decimals in them. And if you're doing that, you'll pick letter A, okay? Let me see what you got. Oh, well, you can just go back over and you can go to A and hit enter, and we'll put that as a 2 by 3, okay? Second quit, second matrix, go down to B, whoops, over to edit first. Yep. And you won't have to, once you get these set up in your calculator, you won't have to set them up again. Oh, that's fine. Don't worry about it if you got an extra one in there. Everybody got that set up so far? So when you hit second matrix, what's going to pop up is you've got A as a 2 by 3 and B as a 3 by 4. Everybody got that? Okay. Yes. Yours is what? Oh, you can, it should if you stay on A. It stayed on A. Okay, then hit enter. And then that one we wanted to be a 2, enter, 3, enter. Then we're going to go second, quit. Second matrix. And then you can go down here. Okay, but you got to go over across to edit. Okay, then go down to B. And then hit enter. And we're going to make that one a 3, enter, 4. Thank you. You're welcome. Okay, did yours too? I don't know where your matrix is at on here.
I'm sorry.
Do you have different keypads with us, or not? It just is the one? Okay. Matrix. Mm-hmm. And I don't know if it would be your row operations. No. Tell you what, let me let you use one of mine for right now, and then we'll look at that later. Because it has it all set up right now for where you're at with it. Okay, we got that so far? So far we're doing good? We got that part in there. So we are down to the part where we are looking at right here on our matrix. So we have both of those in. We've got a 3 by 4 and we have a 2 by 3. So we're to that point. So then once you decide if you want a 2 by 3, which is 2 equations and 3 terms, or a 3 by 4, which is 3 equations and 4 terms each, you need to enter those into your calculator. So I've given you some examples here. So let's go through these examples so we have an idea of what we've got to do to enter these. Now in these, we do what's called, is getting that into a form that we can put onto our calculator. The only key pieces of information that we are interested in putting on our calculator is just the numerical values, okay? So it's said to be augmented if we look at just the numerical values that we happen to have in here. Same thing over here. We would look just at the 2, the -3, the 1 for the z, and the -4, because that's what we're going to put on our calculator. So we're going to walk through this first one first. It says, so go to Matrix C on your calculator. Go over to Edit. And select A because we want a 2 by 3 matrix. And now what we're going to do is hit enter twice. And the reason I hit enter twice is because that walks me across my 2 pieces up here and gets me ready to set up my matrices. So now what I'm going to do to enter it in here is you just hit the number. So 2, hit enter, and it will pop it into its place. Hit 4 and enter. Then a -6 and enter. So I've got my first one entered into my calculator. Then go to my second one. So I have 5, enter. Now if it's got a negative out in front of a y like this is, that's a -1. So -1, enter, and 7, enter. Now, the other thing you want to go back and do before you leave this is double check it. Make sure you've entered it right. So I usually go down with them to make sure. So I have 2, 5, 4, -1, -6, 7. Your calculator will solve whatever you put in there. So if you happen to have put something in wrong, it'll solve it. It'll give you what that answer is going to be. But you need to watch and make sure you put it in right, because that's going to save you time in the long run. Because then you're not going back and redoing your problem and so forth. So everybody got it to that stage? Okay. So now we're going to go, and we're going to go second, quit. So second quit button. I'll clear that A out of there so I don't get it confused with something else. That's entering it. So then what we're going to do is we're going to go second back to matrix. We're going to go to math in the middle, so over arrow to math. And then we're going to go all the way down here to letter B, which is RREF with a parenthesis. Everybody down to that? No? So how I got there, should I get out of here and show you one more time? Okay, how I ended up there is I went second matrix over to math, and then I down arrowed until I made it to B, okay? Then hit enter. It will put it onto your main base piece of your calculator. Are we there? Anybody not there? You have nothing? Yeah, and then just hit enter. Okay, now you got it. Okay, and now we're going to go and we are going to go back to matrix. So we're going to go second matrix. And then we're going to tell it which one we want solved. So we stay in names and we want A because it's a 2 by 3. Hit enter, close it in a parenthesis. Now remember all the work we went through to solve these. We went through and we eliminated or we added things together to make them go away. We substituted. We looked at them as graphs. You got to see all that. Now all you got to do is hit enter and it solves it for you. Kind of interesting that it does that. Now what we need to know on this and solving it is what does all this mean? Well, the first column that you have in your matrix is your X column. The second column is your Y column. The third column is your answer column. Okay, so what this means is I have 1, 0, 1, or I have an X, no Y, and a 1. So my answer to this is X equals 1. And the bottom one is 0 for X, 1 for Y, and a -2. That means Y is equal to a -2. And so my solution to this one that I had here is 1, -2. And so it solved it for you. We good, do you think? No? We'll do more. This isn't the last one. Okay? So let's recap what we did. We first went second matrix. We went over to edit. We selected A, because A was my 2 by 3, because that was the size of my piece. I hit enter twice, and then I started putting my numbers in. So I put all my numbers in, double checked it, made sure I went down so it all matched. Did second quit. Then I did second matrix, over to math, down to B, hit enter, put it in place. Then I went second matrix again. Here, let me come back and see what your calculator's doing. Maybe it's doing something strange. Yep, you are, because now you got to go second matrix. Then you go to names and you want to put your name in. So it solves it. And then put a parenthesis. And then hit enter. And then it will solve it. But you don't have anything in your matrix. That's second matrix. Over to edit. 2 by 3. And see, we put the stuff off of the sheet in there. So we went enter, enter.
Yeah, I never get. I don't know how else to get to that.
And then we did 2, enter, 4, enter, -6, enter, then down to the next line, 5, enter, -1, enter, and 7, enter. Okay, then I double check it, so it's 2, 5, 4, -1, and -6, 7. Okay, on here. So then I go second quit, second matrix, over to math, down to B, hit enter. Then it's second matrix again, and then I want to put my name in. And then I want to close that in parentheses. And then if I hit enter one more time, it solves it. It's all in here. It's all written in there. Okay? And that's not the only one we're doing. So we're going to do a bunch more of them. So hopefully, anybody else stumped on how I get to where I'm getting with these? Are we doing okay with it, you think? Yes? Okay, yes. How did I get the 1 and the negative 2? That's when I went to my names in here. Let's see. Let me go back here. Let's put that part. Right here in this solved piece, this is my X row, this is my Y row, and this is my answers. So the top row has one X, no Y, and a 1. So that means X is equal to 1. In the bottom row, 0, 1, negative 2 means Y is equal to a negative 2. So that's where I get my 1 and my negative 2. Does that help? Answer. Yes. Yeah. It's the rows in here. This row is X row, this row is the Y row, and this row is the answer row. And so when you look at this, because there's no Y, when you go from left to right, there is no Y in there, so it means X is equal to 1. And the bottom row, X is gone now, so Y is equal to a negative 2. So that's where that comes from. Okay or not okay? What do you think? Okay, maybe? Right, we got a lot more to do, so don't worry if you didn't quite follow exactly what happened with this one, because we will do more. Okay, so that is a 2 by 3 matrix, and then the one that's next to it is a 3 by 4 matrix. Notice in this one there's an X column, a Y column, a Z column, and a number column. So we've got all of these separate columns in there. That's what makes it a 3 for variables, or 3 for equations, and 4 pieces to each equation. All right, does that make sense? Okay, so now if we follow the process again, we're going to go, let me clear this out. We're going to go second matrix. The edit key on here means that's where you're going to enter your stuff at, okay? So because this is a 3 by 4, I'm going to go down to letter B and hit enter. So now I've got a 3 by 4 matrix. Everybody get that part? Are we there? To a 3 by 4? Yes? Okay. Now if I hit enter, it's going to move me across the 3 by 4, and it's going to get me to where I can enter my material or enter my stuff. So if we augmented means I'm only looking at the numerical part in here. If I augmented this, I would need to enter a 2, a negative 3, a negative 1, a negative 4, because that's my numbers that are here, okay? The next row would be a negative 1, a 2, a 1, and a 6. The bottom row is a 1, a negative 1, a 2, and a 14. All right? So now I'm going to enter all of these into my calculator so that I can end up having the calculator solve my matrix. So I'm going to put 2, enter, negative 3. Make sure you use your negative sign, not your subtraction. It'll tell you got an error if you do. Enter, negative 1, enter, negative 4, enter, negative 1, enter, 2, enter, 1, enter, 6, enter. And that's, again, all the numbers that are in that equation. That's all I've entered is just the numerical part of each of those variables that I happen to have in there. So now I'm going to enter 1, enter, negative 1, enter, 2, enter, 14, enter. So we good? We got it in there, you think? Okay? Now, you may think that's going to take you longer, but double check. Make sure you put your stuff in. So if I double check it, I'm going to have a -4, a 6, a 14, a -1, a 1, a 2, a -3, a 2, a 1, or -1. Back across, if you use your back arrow, it'll take you to the front where you can see your first one again. 2, -1, 1. Okay? Again, I can't stress it enough, double check it, because you will get an answer. Whatever you put in there, your calculator says, oh, okay, that's what I want to solve, and it will solve it. So if you put in the wrong number, you'll get an answer, but it won't be the right one. So it's going to cause problems when you try to enter it and get your answer into Hawks later on. So you want to make sure you double check them. So then it's second, quit. Then we're going to go second matrix, over to math. And you can also, if you want, you can go second and type a letter B and it'll take you down there, or just down arrow to where B is at. So here's B, hit enter. So I want that on my screen on my calculator, that RREF, and that's the solving of your matrix. So now we're going to go second matrix. Second matrix, well, second quit here, second matrix. And I'm going to stay in names, and this time I want to go to letter B because that's where I've stored it. Whoops, I lost my ref in here. And then down to B and hit enter, then close it in a parenthesis, and then what'll pop up will be your answer. Okay? Your answer is the X column, the Y column, the Z column, the answer column. Okay? Everybody get that okay? Yes? No?
So what you put in the hospital is the last column?
Yes, but you want to make sure that there's a couple things that can happen to these that we'll talk about in a minute. But yes, this last column is your column. So the first one is X, the second one is Y, the third one is Z. And so this is the part you put into Hawks. So my answer to this one is going to be parenthesis 4, 2, 6. And that's its location. Because what we're graphing actually is three-dimensional things when we get into this. So it's a three-dimensional piece that we're graphing. So that's the thing, is because now we don't only have an X and a Y axis where it's flat and two-dimensional. We have a Z coming in now. So you've got a three-dimensional thing. So that point, this point of 2, 4, 6 is kind of hanging out there in space. All right, but it's what allows us to do all of our dimensions and different shapes that we get into, especially in calculus when you get into the variety of shapes that you happen to have, because in calculus you get into 3 dimensions as well. So that's that piece. Questions with this part? On this sheet that's right here that I want to hand it out to you, it walks you through all of this that we just did. Because if you look at the very bottom, it says to get to your matrix, go to the arrow to math. And then if you look on the very back of that page, flip it over because it's got second side on there. The back side is taking you to the information. So then we went down to B, which is that key that we need. So we need this on our screen on our calculator. Go back to matrix, then to names, and we selected A. If we're doing a 2 by 3, we would select B if we're doing a 3 by 4. Then, so down arrow to B and hit enter and close with a parenthesis. Then hit enter and your answer is going to pop up. Okay? Your answer again from the first one is X is the number and Y in the number. The second one is X and the number and Y and the number and then Z and the number. So you end up with your cases in there. So it does walk you through this. So if you are stumped when you get home and start working on this thing and you can't figure out where stuff came from, that's where it comes from, okay? So your X column, your Y column, your Z column are all in there, all right? Does that make sense? Hopefully. Okay. Then in here, there's some special cases that happen. So on your calculator, you might run across this situation. And the situation is where you're going through, and that's why, Joanne, you got to be careful and not just go to that last column. You need to look through, what your calculator is showing you. Just don't hop to the end column, because you might enter stuff in there and it's not right, okay? So be real careful and make sure you got X equals 5, Y equals 2. But then when I get here on the very bottom, we had those special ones before when we solved these. Remember, we had mini solutions? When we graphed a mini solution, it was 2 lines on top of each other, okay? When we graphed, or when we solved this one in using substitution, our variables disappeared and we ended up with either 2 numbers that equaled each other, or we ended up with 0 equals 0. So we knew we had many solutions. Or when we used elimination, all variables and all numbers disappeared on us. Okay, so we had a straight 0, 0 at the bottom, which was true. The other one that shows up is this one. And this one's different because I have X is 5, Y is 2, but when I get down to the bottom, I have no Z. Okay, but I have a 3. So this is the ones that were the ones that came out false when we worked with those. Those are those inconsistent ones. Those are the ones where we had 2 lines that were parallel to each other if we graphed it, where they never touched each other. Where we had in substitution, you substituted something back in and you ended up with 0 on one side and a number on the other. So they didn't match. Or you ended up in addition where your variables all went away but you had a number left. Okay, so that's where this piece fits in. And you can get those also in a 2 by 3, or yeah, 2 by 3 as well, because if you look at these answers that we have here, this one has an answer. So my answer with this one is X is 3, Y is a -4, and Z is 9. This one, there is infinite solutions or mini solutions. And this one here, because there's no Z, there is a no solution. So they show up on your calculator. And I just wanted to show you in here what a 2 by 3 would look like too. This one, X is 5, Y is a -2. This one, I don't have any Y's, and it's all straight zeros across. And so it means there's many solutions. And this one over here also has no Y, and so it means that there are no solutions. So if these pop up, that's what you know about them. Questions with that part? Or do you think we're okay? Now again, in your 8.6, do not solve them the way they're solving them, because we're going to use our calculators to solve everything in 8.6. So make sure you do that. So let's take a look at this one and see if we can get a solution to it. It is a 3 by 4, and so because it's a 3 by 4, what we happen to have in here is that it ends up being augmented. So if we augment it, that means what we're putting in our calculator. So if you ever see that word augmented in your stuff, it means that we're just looking at the numerical pieces of these. So if I look at the augmented one, it's 1, -1, 2, -4. All I'm doing is reading my numbers. The second one is 2, 3, 1, and 1/2. The last one is 1, 4, -2, 4. The sign out in front, remember, tells you the sign of the thing after. So you want to pay attention to that. So stick it on your calculator. How do you put a half? As a division, put 1 divided by 2 in there, and it'll go in as a half. And then hit enter, and it'll put it in. Or since a half is a decimal, you could put it as 0.5 if you want to put it that way in there too. Either way, it will work out. A calculator, we can see it in here. You can still see my augmented piece. So it's second matrix, over to edit, down arrow to B because it's a 3x4, hit enter twice. You can be careful with that part because sometimes you can mess up your 3x4 if you start plugging in your numbers and haven't moved it, but you'll look back up and say, wait a minute, that's not right. So then you have to go back through and fix them. So if you put in numbers, and I'm just going to put all my numbers in here, but I'm going to make a mistake. Actually, two mistakes. Okay, so I think I've got all my matrix in there and everything's great, but I'm going to double check it and see what happened here. I've got a negative 4.5, which is a half, and 4. I'm good there. Next column, I'm a 2, a 1, and a negative 2, so I'm good there. The third, or the other column over, I'm at a 1. Oops, I need a negative 1. All you need to do is up arrow to be on top of it, and then enter the correct piece and hit enter, and it will put it in for you, correcting it. Okay, so if I still check that column, I got negative 1 and negative 3. Oops, I need a positive 3. So I need to just put a 3 into that location. So I can fix them by going over top of it, hitting the number I want, and then hit enter. So if you do make a mistake, you can fix it that way. And finally, 1, 2, 1. But do double check them. I don't know how many times I tell you guys that, and then the next thing I hear is, oh, I got it all. I got a question wrong because I didn't check it. You know, you will get these right every time if you check them, okay? And make sure you enter them here right. And if you don't check that piece, it's when mistakes happen. So it's okay. So I'm going to go second, quit. And then I'm going to go second matrix. Go to math, down to B, hit enter, back to matrix, stay in names, but I want B in there to solve. Close it in parentheses, hit enter, and there's my answer. Okay? So my answer for this one came out to be 1, 0, 0, negative 3. 0, 1, 0, 2. 0, 0, 1.5. So my answer to this equation is negative 3 to 0.5. And that's what each of these equal. First one's x, second one's y, the third one is z when I do that. Okay, make sense? Okay. Yes, everybody good? Think so? Okay, let's take a look at another one. What? You do? Well, maybe I better go back and check my matrix and see if I have what I'm supposed to have in it. Did you check your matrix? Yeah. All right. I have 1, 2, 1, negative 1, 3, 4, 2, 1, negative 2, negative 4, 0.5, and 4. Is that what you have in yours? Did you do the B? Whoops.
Yeah. There's
1, 2, negative 1, 3, 2, 1, 2, negative 4. Okay, so second quit, second matrix. Okay, over to math, down to B. If you do A, it will look different. It won't solve it, okay? But you had B. So then we're going to go second matrix, down to B, enter, close in parentheses.
Is this no problem?
Oh, yeah, 0.2
Okay.
should have been 0.5. Yep, that's what did it. Okay, we good with that one, you think? Okay. Again, double, triple check those and make sure you put them in right. All right, what do you get for this one? If you can see it. helps if I move it down where you can see it. I have one of them chopped off. That's not too good. This one comes out a little bit strange. It's got lots of decimals in it, okay? That's okay. It can have decimals. You would not want to have to solve that one by hand. It would not be fun, okay, because of getting all these decimals in there. But it does come out, and so that would be your answers that you'd put in, okay? Everybody get those, or are you still trying to get it to work? I need help with this part, getting them to work. Jay, you okay? Are they working out okay or not?
I got an answer, but it's not correct.
Okay, let's look. Okay, let's go back, go second matrix, and go over to edit, then go down to B, and let's make sure you put it in right. So you've got 6, -1, it's a positive 5. So, yeah, go over. And let's check the next column, and it's 2, 2, 6. Then it's -5, -1, -2. And then the first one is 3, 1, 2. Yep, you're good. Second quit. Second matrix. Over to math. Down to B. Hit enter. Then go second matrix. Down to B. hit enter, close in a parenthesis, hit enter. There. No, we still don't have the same one. Oh, wait. No.
And the answer, I don't have to.
Last one's all right, but go back over to edit. 6, negative 1, 5, 1, 2, 6, 1, 2, 6. So you need a 1 right
Oh,
there.
Yeah, that's
So
not.
go down. There, now you need a 1.
It's a 2.
No, it's a Z.
This is
Now.
what happens when you have glasses.
Yeah, I know. It doesn't help much, does it? Okay, let's see if we can do another one. I think I got one more up here that we can take a look at and see what we end up with. What do we get for this one? I'll leave still my answers up here. Be real careful in making sure you enter stuff the way it should be. That's why that double check-in stuff is so important to do. This is a good one because it doesn't quite fit on your screen, but what do you notice about it? There's no solutions, exactly, because the bottom has no Z. Notice there's no 1 right here to tell you what Z equals, and because it's all straight zeros across the bottom, it means it's a no solution or a mini solutions. Yep, it'll be a mini solutions for that one. Okay, so hopefully we got that one. We good, you think, with that part? Okay, it's just being extra, extra, extra careful. And let's do that one. So we see what we get with this one. What will its solution be? I guess I should go back here and put no solution on this one. Or not no solution, mini solutions. And here's the new one. And see what you get with that one. you should have x equals 1, y equals a negative 2, and z equals 4. So that should be your solution to this one. Okay? All right. Are we getting better at these, you think? I think a lot of it is just be really, really, really careful that you enter stuff right. Again, because you get an answer regardless of what you put in. So make sure you do take those and do that. There are some story problems that are connected with this. And so let's take a look at this first one. This one's not in your sheet, but you will have some more coming up in your sheet that are connected to these. And again, with these, we're looking at a 3 by 4 matrix when we get all done. Pardon? This one is on your sheet? Okay. The exact same one? Okay. So find it on your sheet then. If it's there on your sheet, let's walk through it and see what we end up with. It says a cash register contains $341 in 20s, 5s, and 2s. There are 28 bills in all, and 3 more $2 bills than $5 bills. How many bills of each kind are there? So they go through and they assign each one of these a letter. The $20 bill is X, the $5 bill is Y, and the $2 bill is Z. So what does our information tell us? So we know how much is in the register, $341. So that is made up of 20 times X, because the number of $20 bills is X, plus the number of $5 bills, plus the number of $2 bills will equal 341. We all agree? So far, so good? Okay. There are 28 bills in all. So what does that mean? So we have X plus Y plus Z equals 28. We all agree? Okay. And then this last piece, 3 more $2 bills than $5 bills. We've had these. What does that mean? We've had these umpteen times. What does that mean? 3 more $2 bills than $5 bills. So it means the Z, $2 bills, there's 3 more than 5. So what does that mean? So I have Z is equal to the $5 bills plus 3. We all agree? $2 bills, there's 3 more $2 bills than $5 bills. So $5 bills plus 3 will give me how many $2 bills I have. Yes or no? We think so? Maybe so? We've had that again in a variety of places. But if I go to enter this into my calculator, I got a problem. These are all in what's called standard form. And we talked about standard form when we did addition. Standard form meant all letters on one side and all numbers on the other. I have that in this one. I have that in this one, but I don't have it in that one, correct? So this piece needs to be fixed. So I need to move my Y over. So if I minus a Y from each side, I got a negative Y plus Z is equal to 3. Now it looks right. Correct? Think it looks right? So I got a minus Y plus Z. The only other piece I'm missing is, what don't I have? I don't have any X's in there. So I need, in order to put on my calculator, I need to have 0 in front of there, because I need to enter 0 for my X's on my calculator. Okay or not okay? What do you guys think? Might be? Okay. So what I did is I've taken this and I've put it on the back side, I think. Maybe I didn't. Yep, I did. I put it on the back side of my page here, and so that we had it in that spot. And so what we did to this one is we ended up with 0x minus y plus z is equal to 3. So now when I stick it on my calculator, and I can do that, I can just stick that whole thing on my calculator and solve it. So what will it come out to be if I put it on my calculator? Well, what would my answer come out to be? So again, go to your matrix, go over to edit, pick B, because I've got a 3 by 4, hit enter, and then put my numbers in. So 1, enter, 1, enter, 1, enter, 28, enter, 20, enter, 5, enter, 2, enter, 3, 4, 1, enter. And the last one is 0, enter, -1, enter, 1, enter, 3, enter. And then double check it. Make sure you put everything in the way it's supposed to be. I'll get my ladybug out of the way here. Sorry that calculator looks so fuzzy up there, but in checking, 28, 341, 3, 1, 1, 2, 1, 1, 5, -1, and my last column, 1, 20, 0. So I got it in there right. Second quit, second matrix, and go down to B. Oops, over to math, sorry. Over to math, down to B. Hit enter, then go second matrix. Select my name, it's under A, or under B, I should say. Go parentheses, hit enter, and there's my number of bills that I would have in my drawer. So I have 15, 5, and 8. So I have 15 $20 bills, $5 bills is equal to 5, and $2 bills is going to be equal to 8. So that's the number of bills I would have in my drawer. Okay? All right or not all right? Yes? Okay. Hopefully that we're doing good with that. All right. Then we got some other story problems. So the cash register one we just did. And so then we've got a local theater. Now your theater ones show up all the time in your homework. They keep popping up. You'll see more than one theater one in there. So we need to read, of course, these carefully and kind of get a sense. We've got to have a 3 by 4 when we're done with these. So we've got to have 3 equations with 4 items to them. So if we read it, it says a local theater has 3 types of seats for a Broadway play. They have a main floor, they have a balcony, and they have a mezzanine. The main floor tickets are $58, the balcony tickets are $49, and the mezzanine tickets are $34. One particular night, sales totaled $67,264. I'd like that haul for one night, huh? I'd go and work that show for one night if I got to go home with that, you bet. There are 370 more main floor tickets sold than balcony and mezzanine tickets combined. The number of balcony tickets sold is 42 more than 2 times the number of mezzanine tickets sold. How many of each type of ticket were sold? So we have 3 things in here, don't we? We have a main floor, a balcony, and a mezzanine. What letters do we want to give those? Now this one's crucial that you get into putting some meaning to your letter. Don't just use X, Y's, and Z's. You will get it all confused when you get down here. Okay, pardon? Okay, F for main floor. And B for balcony. And M for mezzanine. Perfect. Okay, so now when I read on, we know the total was this amount. So what does that mean? Well, that means my prices of my tickets go in here. So I have 58 for F, plus 49 for the balcony, plus 34 for the mezzanine. And that's all going to equal $67,264. You'd hate to have to solve these by hand. Okay. So that's the first row of what I have. Everybody okay with that row and how I got it? All I did was take my prices, put them with my letters, put them with what was made. So then one particular night, the sales totaled this amount. There were 370 more main floor tickets sold than balcony and mezzanine tickets combined. So what does that mean? How can I get that into a statement? Okay, so we're going to have B plus the mezzanine plus 370 is going to equal the main floor. We good with that? Yes or no? Because it said there were 370 more main floor tickets sold than balcony and mezzanine combined. So balcony and mezzanine combined plus the 370 is going to equal my main floor. We good? Okay. Then if I read on, it says the number of balcony tickets sold is 42 more than 2 times the mezzanine. So that means balcony tickets is 42 more than 2 times the mezzanine, or 2 M's. We good there with our interpretation? Again, it's each line, and each line means something in here. Okay, can I put that on my calculator the way it is? What do you guys think? Nah, won't go on there very well because I don't have these guys are not put in the same format as this one. The first stays the same. The second one, I need to put my F over here, but I'm going to minus a B. This one, the second one? Okay. So let's go back up here. There were 370 more main floor tickets sold than balcony and mezzanine. I might have it wrong. I think I do. It should be F plus 370. Yep, yep, yep. Yep, now that I read it a second time, you bet. It should be that instead. F plus 370 is equal to that. So I have F over here. I have minus B minus M is going to equal a negative 370.
It should be F minus 370 more than those two combined.
Nope, because it's going to be whatever the balcony happened to be plus 370 is going to equal what these happen to be combined. There were 370 more main floor tickets sold than balcony and mezzanine tickets combined. More than meaning more tickets. Yeah. When I move the 370 over, it's going to become a negative 370. When I get it solved so it's in standard form, but it's going to be...
Because the balcony and mezzanine combined is 370 less tickets than the floor, correct?
Yes?
So floor minus balcony minus mezzanine would equal 370, correct?
No, because if you had the main floor here, there were 370 more main floor tickets, meaning that I had 370 more of those tickets than I had of these guys with the balcony ones. But when I move the 370 over, you're getting what you're talking about because you're going to have 370 less. Either way, it would be the same, regardless of which way you move stuff. Because it's F plus 370 is equal to the balcony plus the mezzanine. If I leave the main floor over here and I move the balcony back over and I move that over, I have to move the 370 back over. I know. Either way, it works. Then you got to flip-flop it if you move the F over. It doesn't really make a difference. It'll still be the same when you get done. And then down here, we need to move the 2M over. There will be 0 main floors plus the balcony minus the 2M is going to be equal to 42. Then I can stick it on my calculator. So then if I go through and put that on my calculator, I will be good to go with that part. So let's stick it on and see what we get for answers. Let's see what comes up on this whole thing and see if it makes sense of what we have. Because sometimes when you go through and work them out, it may not, our answers may not make sense. So let's go over here to edit, down to B. Plug in a 3x4, so hit enter twice. And I'm going to get 58. Enter 49, enter 34, enter 67264, enter 1, enter, -1, enter, -1, enter, -370, enter. And then last 0, enter, 1, enter, -2, enter, 42, enter. And we do have an error in there because it does not end up giving me the right answers, of course, with that part. So let me into my part that I have worked out here. Because I can definitely tell by those answers that you don't have quite the right answer to this one. That's because it was right in the very first place. This 370 needed to be over in this spot. I know. It's kind of complicated when you have, there were 370 more main floor tickets sold than balcony and mezzanine tickets. It's kind of like that one where we had 3 more $2 bills than 5s. It's that same kind of statement in there. So really in here, this 370 should have been over here.
Or it could have been F minus 370.
Yes, it could have been minus the 370.
Combined, we can have it be 370 less.
Than what the main floor happened to have been, right? So then when we fix this down here, the only thing we needed to fix within our matrix is we put a plus 370 in there instead, we will have what we're supposed to. So let's back to matrix, go over to edit, and hit enter. And let's go down to the second row and make that 370 positive. Then if we solve it, and then go to metrics and B. Oh, I put it in there. Then we get something that looks more realistic in there for our numbers. So it's at 370 that we had in the wrong spot. So they sold 817 main floor tickets. They sold 312 balcony tickets, and they sold 135 mezzanine tickets to this one. So our 370 should have been on the other end. Sorry about that. We kind of got that one all in the wrong location, in the wrong spot. Okay. Backside, there is some more of these. This next one is only a, it's also a 3x4. One. We need a break. Let's take a break. Let's get up, move around. Be back at 9 after. Should work. And getting back in this other story problem here. So it says the sum of three integers is 158. The sum of the first and the second exceed the third by 96. The third integer is 93 less than the first. Find the integers. So the sum of three integers is where we start at. So that means I have the first is x, the second is y, the third is z. So the first statement is x plus y plus z equals 158. So I think that's the easy piece. Second part, it says the sum of the first and the second. So that means the first and the second exceeds. So what's exceeds mean? More? Yeah. The third exceeds the third by 96. So that means z plus 96. And then finally, the last sentence says the third integer, z, is 93 less than the first. So z is means equals, 93 less than, that means a subtraction of the first. So x minus 93 would be what we would get with that. But in this case, not all of these are, they're not in this correct state and correct manner in which we can put them on our calculator. This one is okay. This one I need to move z over. So my new set is going to be y plus z equals 158. Move the z over, so it's x plus y minus z equals 96. And then the final one, move the x over. Z stays where it's at, is equal to a negative 93. But I don't have a y, so I need to put a 0y in there to represent that piece. So I'd need to stick it in there. So then you would just stick this all on your calculator and figure out what your answers would be. So to save a little time, I think you can put it on your calculator, correct? To get your answer with this one. It's just, again, setting them up. One that pops into 8.7, and I know we're not doing 8.7. 8.7 is skipped because 8.7 is doing what we just did today with 8.6, so working with your calculator and doing those. This one shows up in there, and it's, again, kind of like the balcony one, so it's not like we're hopping into something we haven't worked with, so we can set this guy up too. It says the pizzeria sells 3 sizes of pizza, small, medium, and large. So a small is going to be S, a medium is going to be M, and a large is going to be L. The pizzas sell for $7, $8, and $11 respectively. One evening they sold 70 pizzas, so that means a small plus a medium plus a large equals 70 pizzas. And they received $612. So what would that mean? Well, that means the cost of each pizza would have to be put in place. So 7S plus 8M plus 11L is equal to 612. So that's those two statements. It says if they sold 13 more mediums than smalls, how many of each size did they sell? Notice that's still the same as the balcony one that we kind of got all messed up with. It's more than the mediums than smalls. So it's going to be mediums is equal to smalls plus 13. So that would end up being my additional piece in there. So the first two stay the same. When I go to put it on my calculator, but the bottom one, I need to move my small over, so it's a negative S plus M is equal to 13, but I have to put in here 0 large with that one, so I have the L's represented. I cannot leave it blank in my calculator. So that's what I have to do to settle that one and to get it set up where it's supposed to be. Okay? So that's that story problems. And again, by switching it, we got to use our calculator, and so we're going to keep using our calculator when we do our stuff in 8.5, because 8.5 has story problems in it too. And that's the first part of your packet. And those story problems involve interest and mixture problems. And so with these, we're going to use some charted stuff. And the charted stuff, and we're going to set that up, and then from that chart, you're going to pull out your two equations. These are going to all be 2 by 3 matrix. They're not the 3 by 4s. So you only have 2 statements in them, and we'll work with those and see what we happen to have with that. So then the objectives are work with interest and mixture problems. And so our interest one, and this one's probably not in your sheet. I don't think it's in that one. It's not one of the ones that I think I put in. It says James has 2 investment accounts. One pays 6% interest and the other pays 10%. He has $1,000 more in the 10% account than he has in the 6% account. Each year, the interest from the 10% account is $260 more than the interest from the 6% account. How much does he have in each account? So now we need to know that he has 2 accounts. So he has a 6%. We're going to label that X. And he has a 10% account. And we're going to label that one Y. And so what do we gather from our information up here? So if we go to a chart, let me get my sheet of paper here. If we chart this, what information do I have? Well, within a chart, we know there's 2 accounts. We have an interest rate, and our interest is equal to the principal times the rate times the time is what that happens to equal. So we have a 6% and we have a 10%. And so what is our interest rate? So that's the rate. How long does he have them in for? If we look back up above, he has 2 investment accounts and he has them in for a year. So the time is 1 and 1 because that's the amount he has for a year with those. And then what we need to know is what did he put in for a principal into each? And he has $1,000 more in the 10% account than he has in the 6% account. So what in the world does that mean? Kind of goes back to the ones we just got done doing. So if we look at the principal in the 1,000 more in the 10% account than he has in the 6%. So Y is going to equal X plus 1,000, and that's what he would end up having within his principal for what he has. And then it says each year the interest from a 10% account is $260 more than the interest from a 6% account. So what in the world does that mean? So that means that he's got more interest coming in from his 6% account than he does from the other account. So his 10%, which is Y, his interest from it is $260 more than the 6% account that he happens to have. So we end up with our 2 separate equations out of this one. This one has a tendency to be a little bit different than some of the other accounts. And so we end up with this, for instance, and that matches. I've got Y equals X plus 1,000. This one is solved already by moving the 6% back over. And so if I want to put on my calculator, which we can, because we're going to use those for this part, move my X over. Negative X plus Y is equal to 1,000. And then simply put those on your calculator. So let's do a 2 by 3 on here and work with that one for a little bit. So the only difference is that you're going to select A instead of B. So go second matrix, go over to edit, select a 2 by 3, hit enter just like we did before, put my pieces in, 0.1, but I want to reverse these so I get my X in first, so it's 0 or negative 0.06X, And then I want to put my 10 second. So they're in the correct format. So I want to go 0.6 or 0.06, negative 0.06. Enter. 0.1, enter, 260. Then I'm going to put negative 1, enter, and 1,000. Double check. 260, 1,000, 0.1 and 1, and a negative 1 and a negative 0.6. So we're good there. Second to matrix, over to math, down to B. Enter, second matrix. Go to the letter or A is what I want. Hit enter or parenthesis, hit enter, and we will find out his cash values that he has in each account. So his principal in the first one, and pay attention to this because it will ask you for the 6% account and the 10% account. So in the 6%, he has $4,000. And in the 10%, he has $5,000. So that would be his interest rates that he would have involved in that one. Okay, we'll get that out of here. I had some other ones in here, but I think what we will do is maybe go to, we got another interest one that was in place, but we can do some more of those within your homework sheets because I'd like to get your questions that you can take home with you, get some of those done. So we're going to skip that one, but let's go to a mixture one. And a mixture will have two different pieces coming together for that one. So in my mixture, we're going to still have percentages, and we're going to chart this thing, but we're going to chart it with 3 boxes instead of 2 because you're going to have your percent and you're going to have whatever your measurement happens to be. It says how many ounces each of a 10% salt solution and a 15% salt solution must be used to produce 50 ounces of a 12% solution. So the equals goes down here. You have mix 1 and you have mix 2. And you put all of your percentages in one column. So I have a 10%, I have a 15%, and I have a 12%. The 12% is what it's going to equal. So what am I putting together to make this? Well, my measurement that I happen to have is ounces. So do I have a clue as to how many ounces I have? Do I have any ounces? How many ounces of 10%? Do I know? Since I'm in double variables, I can say that's X. How many ounces of a 15% do I have? Y. And how many ounces do I have altogether? Well, they give me that one, which is 50. So if I get my 2 equations out of here, one is going to be here, X plus Y equals 50. The second equation is all of these put together to add together. So if I take the 10% plus the 15% of how much I have is going to equal the 12% of the 50. So 50 meaning the number of ounces that I happen to have. So if I go to put this on my calculator, first equation's good, second equation is good up to this point. I need to find out before I put it on my calculator what 12% of 50 happens to be. So 0.12 times 50 is going to give me 6. So this piece gets replaced with 6. Then I can end up sticking that on my calculator in order to solve it. So I've taken it and they charted it in here, but we still end up getting that exact same equation. So then what my equation would look like is this. X plus Y equals 50. And 0.1x, 0.15y, and this we said was equal to 6, and I can stick it on my calculator then. So if we put it on our calculator, what happens? Go over to edit, choose a 2x3, hit enter twice, put my numbers in, 1, enter, 50, enter, 0.1, enter, 0.15, enter, 6, enter. Just in your mixtures, just make sure you solve that last piece. It won't solve anything within a matrix, so you have to put your answer in there for that. So 56, 1 and 0.15, and 1 and 0.1, so I'm good there. Matrix, over to math, down to B. Oops. Hit enter, select my matrix, which is A, close it, hit enter, and I find I have 30 ounces of one of the first one, or the 10%. So 10% equals 30 ounces, and 15% is going to equal 20 ounces. So I get my answers. This is another reason for this section why we want you to use your calculator, because these decimals end up creating some problems when you start working with them. And since this section has decimals in it, we figured why don't you work with your calculator on it and see what you come up with for the conclusion with those. Okay, so let's go and take a look at the stories that you have in your packet, because I hate to leave you walking out of here without those and not having those completed. So let's take a look at this first one. It says Emma has 2 investment accounts. One pays 5% and the other pays 9%. She has $900 more in the 9% account than she has in the 5% account. And the income from a 9% account exceeds the interest from the 5% account by $200 each year. How much does she have in each account? So what do we know? Well, we've got a 5%. That's X. 9%, we're going to make that Y. So what do we know about what she has? She has 900 more in the 9% account than she has in the 5. That same statement keeps coming up all the time. Notice it's the same as what we had with the balconies, or with the parlor one. It's the same as we had with the pizza one. It's the same as what we have in other places. So we need to say that she has a 9% account. She has more $500 or $900 more. So Y is equal to X plus 900 is what we have with that one. So that is our first statement. Then the second piece, the 9% account exceeds the interest from the 5% account by $200 each year. So you need your percentage in here. And so then it's going to be 0.05x plus $200 because it's exceeding it. So we have more money in that one than we had in the other with it. So you've got to set it up in that manner so you get your pieces in there. And coming up with those. Then to put it on my calculator, I can't put it in this way. So I need to move my X over. Need to move my other X over. And then I can stick it on my calculator. So now I can put it in and get my calculator to work for that one. So that's what happens. So that's my piece with this one. And then you can put it on your calculator, I think, from there. Next one down. Says a savings and loan company pays 7% interest on a long-term savings account. And a high-risk stock indicates that it should yield 12%. So we have 7% on a long-term, I'm going to label it L, and 12% on a high risk, and we're going to make that H. So James has $40,000 to invest, and he wants an annual income of $3,000 $550 from it. How much should he put in the savings account and how much should he put in the stock? So if he has $40,000 to invest, what would that mean in relationship to my L and my H? L plus H equals 40,000. That's good. And then down here, because he wants to earn this income, all that means is I have 0.7 L plus 0.12 H is going to equal what he wants to earn. And so I put my $3,550 into that spot. And then do I have to change them at all? They're perfect, so I don't have to move them, don't have to change them or flip them around at all. And then the next one. Geneva has $18,000 to invest. She puts part of the money in an account that earns 3% interest and the remaining part in an account that yields 5.5% interest. If her total amount of income from interest is $802.50, how much did she invest at each level? Same as the last one we just did, because we're going to label and put our two accounts together. So she's got a 3%. She has a 5.5%. She has a total to invest. So X plus Y, meaning whatever she put in each account, is going to equal 18,000. And then the final piece is what she's going to earn. So 0.03X plus 0.055Y is going to end up equaling $802.50. So pretty straightforward with that one and what you have. And I think the next one probably is too. Jessica has money in two savings accounts. One rate is 8%, the other is 13%. So always on the side of your paper, tell which letter is equaling which. Because when you get to put your answers in, Hawks will only have a box, and the box will say 8% and 13%. And you need to know which one of those, when you solve this, is each one. So be real careful and make sure you know that X is 8 and Y is the 13. She has $450 more in the 13% account. So that means that we have Y is equal to X plus 450 because she has more in the 13% account. And the total interest, so that means 0.08X plus 0.055Y is equal to 237. And then you would need to adjust stuff with that one too to get it for an answer. Yes? When I take my, it's 13. I was on the one up above. 13%, sorry. Yeah, 13%, because that's what she had in her accounts. Yes, it should be 13, not the 0.055. That was from up above. My 13 was here. Okay. So that's interest. Mixtures, again, chart your mixtures. Did we do that one? That was the one we had. Okay. So let's go down one. How many gallons of a 15% acid solution should be mixed with a 35% acid solution to produce 100 gallons of a 20% solution? So chart this stuff, because as you chart it, you're going to end up finding your values that you happen to have. So we have a 15% mixed with a 35% is going to equal a 20%. We all good there? Then we're measuring in gallons. So how many gallons of the first one do I need? X. How many gallons of the second one? Y. And the total is 100 gallons. And then off over here, you multiply these two together. So 0.15x, 0.35y is equal to 0.2 times 100. And your two equations, if you chart stuff, your two equations are right there. So my first equation is x plus y equals 100. The second equation is 0.15x plus 0.35y is equal to 0.2 times 100. And make sure you multiply this piece out and end up with really replacing it with 20. Don't put it in as a math problem into your matrix, because it will not solve it, okay? So it won't solve that one. And then the next one, Peter decides to mix grades of gasoline in his truck. He puts 13 gallons of regular and 7 gallons of premium for a total cost of $42.68. If premium gallon costs 24 cents more per gallon than regular, what is the price of each grade of gasoline? So what don't we know? Well, we don't know the price of the gasoline, right? So he puts regular, premium, and so the cost, he has 13 gallons of regular plus 7 gallons of premium, and that equals $42.68. And then it says that premium gasoline costs 24 cents per gallon more than regular, so premium is equal to 0.24 plus regular. We will end up with our two statements and our two equations. Does that make sense with this one? What do you think? Okay. And what about the last one? See what you guys can do with the last one. But again, I need your calculator. So this would end up being, of course, your equation that you would happen to have with that one in working it through. So again, chart stuff with your mixtures. Make sure you put them in there and figure out what you do have to do with those. Next time, make sure if you run across anything you don't know how to do, bring it back, because we'll stick it up here and go through and make it work. So next time we're going to finish up chapter 8. Again, we're going to get back into graphing lines. Pardon? 8. 8.5 and 8.6 are your homework assignments. You might want to do it just as we did in class. Do 8.6 first, then go back and do 8.5.
On that last one you're working on, what is that last?
14.52, because I took 33 times 44, or 0.33 times 44, and I got 14.52. And I have to pad back to put it in my calculator. You good now, Jay?
I like to have, I take that out.
Yeah. Okay, good. See you, Nick.